Hi, our project title is Dota 2, Explanatory Data Analysis and Prediction. Dota 2 is a hot multiplayer online battle arena, and it has a huge number of followers around the world. For this project, the dataset from Kaggle, posted on 2016, were used. Here is the data, and there are in total 18 CSV files containing exhaustive information about players, heroes, match records, and so on. The total size for the dataset is around 2 GB. We endeavor to utilize as much information as possible to get more trustworthy results. Some files were also used as the testing data for model evaluation. Here is the technologies. For this project, we use the basic statistical method to conduct ETA. We utilize the classification method to build model and make prediction. We also use some visualization method and graph analysis method. And we use the R to create the Shiny app, and we use Python and System-G for the graph analysis. Based on data, we have achieved the following outcomes. We have conducted explanatory data analysis to evaluate the player's performance, and we achieved recommendation for hero selection at the beginning of the game. We also make prediction by logics regression using player and hero information as features. Moreover, we conducted graph analysis between heroes, and we identified the most significant heroes and the combination of heroes. For the first two outcomes, we choose to create a Shiny app to show the result. Due to the large amount of followers of Dota 2, we think that our result of high business value. For teammate selection, evaluate the performance of a specific player is crucial, and a good hero selection could increase the winning probability for a team. And as we know, Dota 2 Worldwide Tournament is held every year, and accurate prediction could bring gambling benefits to some people. And if we can identify the relationship between heroes, it will provide insights for team training. Here is the EDA part for players' performance analysis, and here is a demo. In the player performance app, once the player is selected, a radar chart with 6 different indicators will be shown. And also, we provide a historical winning rate for that chosen player. Take number 508 player as an example. We can see that that player doesn't have an outstanding ability among all the players, and among the 6 indicators, the experience gaining abilities is higher for him. Also, his historical winning rate is only about 50%, which is not desirable. Thus, we can conclude that the player 508's performance is not excellent, so he may not be a good candidate for teammate. This app enables people to obtain the information easily and quickly. And we know that here are some missing player IDs. For example, if we type in 18, there is no player 18, so the app will show, sorry, we don't have information for that player, please try another one. And you can try another one, say player 17, and you can see the performance analysis for that player. Here is the EDA part for hero recommendation. As we know, at the beginning of each game, the 2 teams take turns to select heroes, and we want to provide recommendation to the team at each stage based on all the information of the selected heroes. Here is a demo of our Shiny app. In the recommendation app, people could type in all the selected hero IDs. At each step, the app will give 5 recommended heroes, which will give the highest winning probability. At the very beginning, since we have no information, so the app will recommend 5 heroes which have the highest historical winning rate. And here is the 5 hero recommendation. And now we can change the selected heroes. For instance, we can type the selected hero IDs. Here is for team A, here is for team B. And we can see that our app will give the 5 recommended heroes for team A for the next selection. And we can type more selected heroes to see how our app will work as the process goes on. And we can type say 2 here, and type 11 no and 7 and 11, and based on the new informations, the system will give the new recommended heroes based on the information. And we can type more selected hero IDs, say number 2, number 6, and unfortunately for these selected heroes, our app said that there is no recommendation. It is because that for these 2 specific combinations, they do not appear on the historical data, so we do not have relevant information to make recommendation. Here comes the prediction part for our project. To make predictions, we use the logistic regression. And as we know, the players and heroes are 2 very important factors that will affect the outcome of the game. So we use the average player ratings, the average hero winning rate, the average hero last hit, and the relationship among all the 10 heroes as features to make prediction. And we integrate the prediction model into the Shiny app. We want to make prediction when a new game just starts. Here is the demo for the Shiny app. Here is one example, and we listed all the players' IDs for Team A, Team B, and all the hero IDs for Team A and Team B. And the system will give the win probability for Team A. And with all these informations, the win probability for Team A is around 54%. Now we can try another combination. This time, we make the Team A consisted of players of higher rank, and Team B consists of lower rank players. And we see the result. We just changing the IDs. You can see as we change the information, the winning rate is changing, and type in all the IDs of players that we want. And we can see without the players of higher rank, the win probability for Team A is higher than the previous case, which suggests the volatility of our prediction model.
As for the graph analysis part, here is the page of IBM System G Visualizer, where the hero's synergy and suppression graphs are constructed in advance. Here we show the suppression graph as an example, with 110 nodes and 11,990 edges. Although the original graph is too complicated to inspect it, as we see here, it's a kind of mess, isn't it? But we can do query to simplify it and find the useful information from it. Specifically, we want to use two edges variable, winning rate and total number of games, is the query condition. The winning rate indicates the strength of the relationship, while the total number of games denotes our confidence with the relationship. So here we will set up the query condition. Let's click query by edge property, and we attach a winning rate over 0.65, and we add one more rules to filter, to scream out the nodes with the total number of games over 200. I'll filter out screen out the edges. So let's see the query results. Here's the result. Graph will be created as a result, which is much clearer. In the graph, the node label denotes the hero names. The hero variable shows the winning rate of one hero against another, indicating by the direction of the edge error. The size of the node is proportionate to the degree of the node, which shows the importance of the hero. If a node has many degrees, it may be a relatively powerful or weak node of the weak hero of the game. The relationship between heroes corresponds to our knowledge of the game. Thus, we can tweak the query thresholds to detect hidden relationships among heroes and give deeper insight of the game.